But to finish our C++ only example, we can create and configure a static mesh component, making sure that we manually enter the right offsets to match what we previously configured in the editor, and then we can spawn our muzzle flash particle effect when the weapon is fired, using the exact same function that we called from blueprints. So this works, but let's see how we can make use of blueprints for these cosmetic details. First, let's handle the particle effect. We don't want our C++ class to be concerned with specific visual effects. We just want it to be able to dictate that effects should be spawned. So we can declare a function called playFireEffects and add the blueprint implementable event specifier. That gives us an event that blueprint subclasses can respond to, and all we have to do in C++ is call the function to fire that event.
Wait.
Respond to.
Oh, blueprint implementable event. So you can kind of determine if it's going to be shown as a function or as an event in blueprints.
And all we have to do in C++ is call the function to fire that event. Next, let's look at the mesh component. If our C++ code needed to have control over the mesh, for example to turn collision on or off at runtime, then it would be perfectly reasonable to
Yeah, he's going to instantiate everything in C++, and then in blueprints you're going to have control over the location and all of that stuff, but here he's going to have the reference.
Declare this component as part of our C++ class. We could just leave out the asset reference and let the blueprint subclass take care of fully customizing the mesh component. But in this case, the mesh is purely for show, so we'll leave it out of the base class entirely. So now, if we head into the editor, we can open up our original weapon blueprint, which is still just an actor blueprint. We can delete the data and functionality that we've refactored into C++, just leaving us with our particle effects and our mesh component, and then we can reparent the blueprint to make it a subclass of our new C++ weapon class. All we have to do is hook the playFireEffects event up to our particle effects, and our weapon is done. So now we have a blueprint that extends our C++ weapon class. When that blueprint is compiled, we end up with a new class of weapon that's generated from our blueprint. The only question now is, how do we use our new blueprint-generated class instead of the base class that we specified in C++? All we have to do is make a blueprint subclass of our pawn and change the default value for the weapon class property. And then we can use that new pawn class as the default for our game mode. This way, we maintain a clean design where the dependencies only flow in one direction. We have a higher-level blueprint layer that's built on top of a lower-level C++ layer. And each layer...
Yeah, this is not bad if you really want to work with C++. For a lot of these things, you could just do it in blueprints and it would be fine. But if you really want to do with C++, maybe you have like a team where there is like few C++ guys, few blueprint guys, and they both need to work on separate classes. Then you can make this distinction, and then one team can work on the higher level and the one team on the lower level. But for small teams, I would say do everything in blueprints, find whatever is very performant, some whatever for loops, bunch of casts, whatever is very performant. When you profile it, send that to C++ and deal with it. But yeah,
handles a clearly defined set of responsibilities with minimal overlap between layers. This is a very simple example, but I hope it demonstrates the principle. This pattern right here, this approach of using blueprints and C++ in a structured, complementary way, this is the conventional approach that I alluded to earlier, with the line drawn right down the middle. This is the traditional, classical model, and for a team with the requisite skills making a moderately complex game, this tends to be the optimal approach.
Yeah, I wouldn't do this for like indie or solo teams. This would I think be for like single A, AAA games, where you have this really clear, nice distinction. But if you're doing solo stuff, like all of this could be done in blueprints with way less hassle. But then there wouldn't be this nice distinction where you do all the low-level stuff in the C++ and all the high-level in blueprints.
As we've already discussed, though, Unreal gives you plenty of flexibility. So if you're making something on a smaller scale, or if you're lacking in C++ experience, you're not sunk.
Hell yeah.
As an example, we don't necessarily have to pull entire types down into C++ if we don't want to. If you make a class that extends Blueprint function library, you can add static, blueprint callable functions that let you take full advantage of native code from anywhere in your project. So we also could have kept our pawn and weapon classes in blueprints and just refactored individual functions into C++ where
Wait,
needed classes in
Did he make like a library or some sort?
anywhere in your project. So we also...
Yeah, I'm not familiar with this. What did he do here?
Also could have kept our pawn and weapon classes in blueprints and just refactored individual functions into C++ where needed.
Yeah, this is like a little
So we've
function
gone
library.
into some detail with these examples. I appreciate you bearing with me, and I hope you've gained a better understanding into what happens under the hood when your code is compiled and run, how real-world projects are typically organized to ensure a clean and maintainable design, as well as the implications that C++ and blueprints bring to both performance and project organization. Now that we're on the same page about those more nuanced questions, let's wrap up by looking at some of the more cut-and-dried differences between C++ and blueprints. The cases where
Okay, let's see. Assets and visuals, runtime performance, scripted behaviors, fundamental code, iteration speed, engine functionality, accessibility, external libraries, discoverability, diffing, and merging. Diffing and merging. Diffing and merging is pretty good right now. There is, I can't even show it anything because it's, I have the project open. But you have some nice diffing now in Blueprints where it shows you from a different branch or from the, I don't know how you would call it, from the depot. It shows you the differences that you made in your own branch. So it kind of shows you the differences visually, where you actually see the nodes that you changed, you see the functions that you changed. So that's really nice.
one is, dare I say it, better than the other. Blueprints are better for dealing with assets and visual effects. Your C++ source can only blindly speculate about what assets will be present at runtime, whereas blueprints are assets. When you're editing a blueprint, you can see all the assets in your project right in front of you. You can use them and see exactly how they make things look and sound immediately and tweak them as needed. When your C++ code directly references an asset, that creates a dependency between your compiled game module and the asset. If the asset changes, you need to go all the way back to the start of the build pipeline and manually update your source and recompile. When your blueprint references an asset, that just creates an asset-to-asset dependency, which the engine can handle quite naturally. Blueprints also have a clear advantage when it comes to scripted sequences. If you're working in an event graph as opposed to a function graph, you can take full advantage of events and latent functions in order to write asynchronous code in a way that's incredibly straightforward and intuitive. If I want a character to move to a code in a way
I actually
that's
had
incredibly
a
straightforward,
lot of trouble when I was learning delegates with these connections. This just didn't make much sense to me. I didn't quite get it, but now it's way more intuitive. Like this is an input variable, which is an event, which is this event, which connects it to another event. And this is kind of the connector. But yeah, when you're kind of starting out, this kind of looks weird. You like never see this in any other context except event dispatch and creating delegates.
Forward and intuitive. If I want a character to move to a certain spot, then wait 3 seconds, then wait for a door to open, checking every half second, then shoot at an enemy until it's dead, then continue through the door, in Blueprints, we can basically express that sequence of events directly in a straightforward, self-contained graph. You can technically do the same sort of thing in C++, but you're limited
Yeah, it's gonna look like a mess.
to using timers and callbacks, which is much less expressive and obviously much harder to tweak and iterate on. Scripted events like this are often implemented using Sequencer, which allows you to use event tracks for easy integration with your level blueprint and with blueprint callable functions on your actors. Event graphs also allow you to use timeline components, which are a very handy way of animating properties or effects over time. You can do similar things in C++, but that typically involves either referencing and sampling curve assets, or else figuring out an equation that allows you to express your animation directly in code. Blueprints allow you to test and iterate very quickly. The entire blueprint authoring experience takes place at runtime in the editor, with no need for an offline build process.
Yeah, this is one of the big things for me. If blueprints took the same time to build, compile, whatever, have to restart the engine or something, if it took that amount of time every time I was changing something in blueprints, I would probably be way more inclined to use C++, but since they are so convenient, it's just like whatever, you can just click on 2 buttons and it's going to be done instantly. You can just play.
You can see how something runs, make a quick change, and go straight back to play in editor. You can poke around your event graphs while the game is running to inspect values and debug your script execution. You can pause the game while it's running and tweak properties to your heart's content. Blueprints are accessible to a wider user base. Jumping into the editor and playing around with blueprints serves as a great starting point for people with limited C++ experience. And even if you're a C++ wizard yourself, not everyone is. When artists and designers and other team members can safely and easily contribute work toward a wider set of problems, your project and your development cycle will be...
Yeah, the honest, I understand why blueprints were in this way usable or useful like a few years ago, but right now, since I know blueprints decent amount, I kind of don't want people that don't know much about coding or even have much blueprint experience to kind of touch blueprints, just because there is so many inefficient ways to do stuff. Like if I was letting an artist touch the blueprints, I would be very clear. Okay, you can do this, this, and this on these places, and that's kind of about it. Or you have this data asset, change these values, and that's about it. I don't really want them to create like some bunch of functionalities or code, because it's going to be so inefficient that I'm going to have to jump in and refactor it and change it myself, which then kind of removes the point of doing someone else doing it. But yeah, I guess for prototyping is nice. Like if some artist wants to do some feature, but he's not sure if it's going to work, instead of like me testing it for him, he can just create a new level, few blueprints, test it out, send it to me, and then we can say, okay, it works, it doesn't work, and then I can refactor it, or someone that knows blueprints well can refactor it in like more performant way.
Better for it. You still need skill and quality control either way. Just as you can write good or bad C++, you can also write good or bad blueprints. But buggy C++ code tends to do more damage to your workflow than buggy blueprints. Blueprints typically don't cause outright crashes. And blueprints are discoverable. Everything is integrated. All the types and functions you can use are laid out for you in the blueprint editor, so you can get a sense of...
Yeah, I guess I didn't think about this much, but this is true. In C++, you, especially if you're not like proficient, it's kind of hard to, okay, I need to look at this class and then I need to wait for my, I don't know, is it called like IntelliSense? I need to wait for my thing to show me all the available options, and it's a long list of random stuff. Half of them I don't even care about. In blueprints, you have this nice list, you type stuff, it instantly shows you. There is like color coding, so you know if it's like an object, integer, enum, or whatever. It's really nice.
What's there for you to leverage before you ever start reading documentation. And the quick iteration and visual feedback makes it easy to test things out and figure out how they work interactively. If you're a newcomer to Unreal, even if you have C++ experience, it's not a bad idea to start by playing around in blueprints. The things you learn using blueprints tend to be directly transferable to C++. So what about C++? As we've seen, C++ can give you maximal runtime performance. Your C++ code can be fully optimized at compile time for the platform it's going to run on. By the time your source is compiled to machine code in a fully optimized release build, it's down to the bare metal, with nothing superfluous about it, no overhead. And even though blueprint nativization can make a significant difference in some cases, it still adds some fairly wonky complexity to your project's build process, and that's a cost you have to weigh. And anyway, C++ is the best place for code that's truly fundamental to your project. Any types that need to be referenced in both C++ and blueprints should be declared in an appropriate C++ module. Be referenced place for code that's truly fundamental to you should be declared in an appropriate C++ module.
Okay.
And C++ is also just solid. Your C++ source is just plain text. It's simple and straightforward. It doesn't depend on anything besides other, more fundamental C++ code and libraries. It's written in a highly standardized, extremely well-supported general-purpose language. It's unambiguous. Its meaning or behavior or correctness will not change for any reason except an upgrade to your engine version or compiler version. So C++ is the ideal place for any code that's fundamental to your project. Anything that you need to be rock solid and easy to read, understand, extend, and maintain. C++ also exposes a wider range of engine functionality, the sort of stuff that tends to be useful for that kind of...
Yeah, this is like a big thing where, except for performance, another thing like I was talking about Minecraft is basically if you have something that you just don't have access to in blueprints, like you have to use C++. Catching performance stuff and then, doing stuff that you just can't do in blueprints.
Kind of fundamental code. You can make full use of the logging system to instrument your code with useful diagnostic output. You can add assertions to enforce invariance and ensure that your code is running under the conditions you expect, with helpful error messaging when things go wrong. You can define custom console variables that let you control your game's behavior in real time at runtime by tweaking values in the console. You can add custom stat categories to capture detailed profiling information that lets you measure the performance impact of individual systems and features within your game. You can exercise more control over how your types and interfaces are exposed to other parts of your C++ codebase, to Blueprint script, and to users in the editor. You can control network replication more precisely with custom rules for priority and relevancy, and you can make use of advanced features like the replication graph system. You can create raw TCP and UDP sockets to send and receive data at a lower level, and you can use the HTTP and JSON modules to communicate with web APIs. You can define rules for serialization to dictate how structs and other types are written to disk or compressed for replication.
There are some serialization options, I think, in Blueprints also, but there's probably way more detail in C++.
You can hook into lower-level events that occur during saving and loading, allowing you to manipulate data on load and facilitate backward compatibility. You can add editor-only code and data that's specific to the editor or the cooking process, and that gets compiled out of non-editor builds. You can add editor modules that allow you to extend the editor with new UI elements, new asset editor windows and importers, and new editor modes and viewport tools.
There is something like this in Blueprints, of course less customization, which is editor utility widgets and Blueprint utility widgets, I think. Utilities, I'm not sure how they're called. But you can basically create custom stuff, not to this extent where you can actually have custom tabs or custom buttons or something, but you can have like custom tabs and stuff like that where you can do some editor stuff, run like functions and events in editor, so you can create like your own little tools to manage stuff in your game.
You can hook into a wide range of engine and editor delegates to run custom code when different events occur. And from a C++ module, either as part of your project or in a plugin, you can integrate third-party libraries. If there's a C or C++ library that you want to incorporate into your game, you can build it as a static or shared library for your supported platforms, update your module build rules to include it and link against it, and then use that code in your project or plugin. This is one of the most obvious advantages of C++, but also one of the most powerful. Literally anything that a computer can be made to do, you can have your game do. Lastly, from a workflow perspective, C++, unlike Blueprints, can be diffed and merged very easily. This may not be a huge concern for smaller projects, but on a larger team, this becomes pretty important. Before you submit a change to your
Yeah, I'm not sure about large team. You have some diffing in Blueprints, but when it comes to large team, yeah, you probably, especially since I don't think you can do it externally, you can't open Git and diff Blueprints there, but you can diff Blueprints in editor. So it will probably be harder to diff Blueprints than C++. Yeah, I'm not sure how bad this is in like big teams, but for small teams I think it's not a big deal.
Your project's version control system, you want to be able to diff the files you've modified so that you can review exactly what you're changing. Or you might find yourself looking over the change history to see how a system has taken shape and changed over time, or to track down a bug. In those cases, you want to be able to quickly see how a file has changed at each revision. Ordinary source code is plain text, which is trivial to diff. There are plenty of tools that can present you with a line-by-line breakdown of the differences between two different versions of a text file. Merging is another key benefit of plain text. Two people can work on the same source file simultaneously, and the version control system can automatically merge their changes together. There can be merge conflicts where something can't be resolved automatically and a human has to step in, but the majority of changes to C++ source can be automatically merged. But blueprints are binary files, and critically they're dependent on your project's editor build. That is, in order to view them or edit them or make any sense of them at all, you have to boot up the editor and load your project. That makes it substantially more difficult to diff and merge. That is, in order to view, and critically, they're dependent on your project's editor build.
Did he go to 64?
They're dependent on your project's editor build.
Yeah, I never did this, so I'm interested.
That is, in order to view them or
no, 128, what? Okay.
Or make any sense of them at all, you have to boot up the editor and load your project. That makes it substantially more difficult to diff and merge blueprints. Luckily, the editor includes a built-in tool for diffing blueprints, and it works pretty well in simple cases. If you just want to review your changes before you submit, you can do that very easily from the editor. You can run into trouble, though, if you're diffing against old revisions that depend on types that no longer exist in the current build. Doing code reviews on blueprints is technically possible.
If you're like, if there is different versions, like you went from Unreal 5.0 to 5.1 or something, there might be some like things that blueprints are now working a bit differently. But yeah, I guess that in C++ is not that big of a deal.
But it's a much more cumbersome process compared to looking over source changes. For merging, blueprints aren't really mergeable. There's a built-in merge tool that comes in handy when you need to resolve conflicting changes to a blueprint. But any merge on a blueprint asset always requires human intervention, even when there are no conflicting changes. The merge tool is fairly limited. It basically shows you the relevant changes and lets you pick one version or the other to accept. Beyond that, you need to fix things up manually. So conventional wisdom is that you should treat blueprints like any other asset, where checking out the file means you're locking it for your exclusive use. Ultimately, these are acceptable trade-offs. But given how powerful and useful blueprints are, I do think it's a shame that they carry these caveats when it comes to how they can be used in a collaborative workflow. For me, this is the one thing that I really unambiguously dislike about the move from Unreal Script to blueprints. And finally, that brings us to one last factor: personal preference. It's okay to have preferences. I think blueprints are great, but sometimes I still miss Unreal Script because having to write code by dragging little lines around with a mouse can start to feel very cumbersome when you already know exactly what you want to type. It's okay to...
Same for typing, okay? This ain't one-way street. Sometimes I know I just want to spawn an object, or I just want to move this and I have to write 5 lines for this with random stuff in brackets. And I can just right-click, type what I want, and click enter, and the node is there.
To dislike some kinds of work and enjoy others. We all have preferences. But we have to maintain some sense of self-awareness to make sure that we're not letting our personal preferences cloud our judgment. The work that goes into making a game is complex, and it's a team effort. When you're making decisions that affect the whole project and the whole team, like how to balance C++ and blueprints, you have to weigh a host of more important factors. What's best for performance? What fits best with the overall design of the project? What's going to be the most maintainable? What's going to let us get the job done given our schedule and budget constraints and based on the makeup of our team? Usually you'll arrive at an answer well before "I don't like typing well-formed C+" or "I don't like hooking nodes together" becomes a relevant factor. But if all else is equal and either option is valid, or if you're just making games as a hobby, then by all means you should take whatever approach you find more enjoyable. After all, people tend to do better work if they're having a little bit of fun. But no matter your background or experience level, I'd encourage you to try and get your feet wet with both C++ and blueprints. If you take your time with them and get an understanding of where their respective strengths lie, I think you'll find them both very fun. So there you have it, my manifesto on blueprints and C++ in Unreal. Thanks for sticking with me, and I hope you learned something new. Special thanks to the patrons who helped make this video possible. This is a periodic side project for me, and I'm grateful that I'm able to take my time, cover the topics I feel qualified to speak on, and put in the work required to end up with a video I can be proud of. Your support on Patreon, along with your feedback in the comments and your willingness to share this video elsewhere, are essential in allowing me to do that. So, thank you.
Yeah, check this guy's Patreon, he's pretty cool. Check his Patreon, he's pretty cool, yeah, he has really good videos.